All right, trig review. Like I said, this is going to play a big part not only in the graphing portion of the test, probably most evident in the graphing portion of the test, to be honest, but then also in the on the multiple choice. There's going to be some trig, type of questions for sure, because trig is that's the if you recall the way that we tried to break things down. First semester it was all about functions. Second semester it's mainly about trigonometry. So sure, did we venture away from that a little bit, especially in chapter 10? But we were using aspects of trig even within chapter 10. Again, you had to know your unit circle. You were asking yourself, what's the sine of pi over 2 on a regular basis, those types of things. But the trig that we're getting into, like I said, we're going back a little bit further and talking more about the graphing here. So hopefully we're remembering the structure of some of these trig equations to where either the sine or the cosine, again, tangent would follow the same pattern, but the sine and the cosine is definitely where we want to begin. If we had something looking like this, y equals a times the sine of quantity bx minus c all plus d. Remember that leading coefficient, what we're calling a, that's going to help us. That's going to lead to the amplitude of the graph. What is amplitude, please? Could somebody remind me what amplitude is all about? Yeah, it's how much of a stretch we're doing vertically. So again, we have our parent function. So how much are we deviating from that? Are we stretching it? Are we condensing it? But that's what the amplitude is going to tell us. So the way we calculate amplitude is the absolute value of A. B, on the other hand, within the coefficient that's attached to the x term, that's going to help us with a couple of things. Not only with where we are located in terms of our, you might remember what we call our starting point. C over B comma D. But again, that's going to play a major role in that, but it's also going to affect the period. Because if we have a sine or a cosine, remember the period is 2 pi over B. Does anybody remember what is the period for tangent or cotangent? Because it's different. What is it? It's going to just be pi over B. So not 2 pi over B like the others, but pi over B on a tangent curve. C, once again, that's going to help us determine how much you're shifting right or left. For us, when we're doing the framing method, which was the way that I was really trying to emphasize this year, and I'll continue to do that again today. But that phase shift, again, we're less focused on, okay, let's shift the whole thing to the right or to the left. Instead, we try to build a frame, and so this factors into what we call our starting point. And then D, that's our vertical shift. Again, how much we're moving up or down. But once again, if we can correctly identify that starting point, that's going to take care of some things. So just out of curiosity, show of hands, how many of us are feeling pretty good about A, B, C, and D? We're remembering this, it's coming back to us a little bit. Okay. All right, so this is another way of looking at it. Again, just has a little bit more broken down in terms of the notes. So again, tells us what each of the variables are intended to do. Again, that big one being the period, though. So 2 pi over B. Let's not forget what that represents, how that could affect things. I went into greater detail on amplitude, how we're stretching vertically. Period, we're stretching or condensing horizontally. Is what the period's going to do. It's how quickly do we cycle through one time through one trip around the that unit circle, so to speak, or circle. Hi. Okay. All right. Thank you. You bet. All right, so again, amplitude, absolute value of A, that's going to lead to the range of the function. So how far are we stretching? What's the lowest point? All the way up to what's the highest possible point. If the amplitude is negative, that's when the graph has been reflected. So the way we've always looked at it is that if A is negative, we're experiencing a reflection in the graph. Once again, the starting point, I would circle this or highlight it or whatever it is that you need to do. C over B comma D. That's how we're going to identify the starting point. Because hopefully, if you remember anything from graphing trig, is that if we struggle to identify the starting point, we're not going to accidentally just graph everything else where it's supposed to go. If we miss on that starting point, everything's going to be a little off. So it's of the utmost importance that we get things started off initially with that first point being in the correct location. Also, B gets larger, period's going to decrease because remember we're doing 2 pi divided by B. Okay, first example that we have here, excuse me. We want to identify the amplitude, the period, and the starting point for each of the following. We also want to note whether or not we are reflecting. So what may be beneficial is to just go through and let's start off and identify A, B, C, and D. So with your help, please, on this first one, what is A? A is 4. What is B, please? 2. What is C, please? We want to be careful here. It's going to be positive pi over 3. Good. It's the amount being subtracted from the x term. And then finally, what is D? This is where we actually would include that negative. All right, so I'm noticing that A is positive. So what does that tell us about a potential reflection?
There is
no reflection. No reflection. Again, if A were negative, that's when we would see a reflection. All right, but it's not. So A is positive. We're good to go. What about my amplitude? What's my amplitude in this one, please? How do I find the amplitude, just as a reminder? We find the absolute value of A. So the absolute value of 4 is still 4. So the amplitude is 4. Good. What about the period? How do I find the period on a sine problem, please? 2 pi divided by b. So when we take 2 pi and I divide it by b, which is 2, are we going to say that the period is just pi? Okay. Then, what else did we talk about? Starting point, I believe, is the other thing that we were asked to identify. So remember, off to the side here, what starting point is all about, if you need to see it again, c over b, comma d. So we are creating an ordered pair. So when we put c, pi over 3, over b, which is 2, and then I'm going to put that next to d, which is negative 2. We have some cleaning up that has to happen there. Okay? So I know that we've asked this question 10,000 times this year, but when you're dividing fractions, what are you really doing? You're going to multiply by the reciprocal. So we're really going to take pi over 3, and I'm not going to divide by 2. Instead, we're going to think about that as multiplying by 1/2. So when we multiply across, then what do we say pi over 3 times 1/2 is, please? It's going to be pi over 6, comma, d is still. All right, guys, how do we feel about finding the amplitude, period, starting point, and the fact that there's no reflection? Are we feeling pretty good about that? Okay, luckily in this problem, we're done. We don't have to go any further, but usually the next step would be to actually draw in the graph. Now let's try this again on the next problem. Like I said, don't think that anybody is surprised to hear me say that I would highly encourage you to begin with identifying our variables A, B, C, and D. This is typically the way that we have been pushing you to do these problems all along. But with your help, what is A? Negative 4. What is B? C is negative 3 pi over 2. And then D, how much am I adding to the back side of this? Nothing, right? So 0. All right, so with that, this time I'm noticing that A is negative. What does that mean? There is a reflection. All right, what about my amplitude this time? Isn't it just A? So is it negative 4? Is that how that works? It's the absolute value of A. So the absolute value of negative 4 is 4. The period, this time it's a cosine problem. Does that change what we're going to do for period? Nope, not until it's a tangent problem. But again, cosine, we're still doing 2 pi over b. So when we take 2 pi and divide that by 1, we still have 2 pi. And then my starting point. All right, c over b. When we have negative 3 pi over 2 and I put that over 1, we still have negative 3 pi over 2, comma d, which is 0. All right, how do we feel about this incredibly important step here? I know that the next step is obviously to draw the graph, but if we struggle with this, then like I said previously, the graph isn't just going to accidentally come together. This is the structure that that we're trying to set up in advance. How do we feel about these, guys? Is it all coming back to us? All right, so let's go ahead and graph one of these bad boys. All right, so we're going to graph a sine curve. As we can see, we have y equals negative sine of quantity x plus pi over 2, all plus 3. So let's go ahead and start just like we did before. We want to figure out whether or not we're reflecting. We want to find the amplitude, period, and the starting point. That's got to be phase 1. Once we have those pieces, then we can actually come over here, build the frame, draw the graph. So I could use some help here. What is A in this problem? Negative 1. What is B? 1. What is C? Negative pi over 2. And what is D? 3. Perfect. All right. So I'm noticing A is negative. What does that mean for us? Reflection. Yeah, that's going to be reflected. All right, so we have a reflection. What about my amplitude? What's my amplitude in this case? Just 1. That means that we're not vertically stretching this thing at all. Again, we're reflecting it, but we're not vertically going to stretch this thing. It's going to stick to the parent function. Period. Remember the way that we identify the period? It's a sine or a cosine, secant or cosecant. For that matter, we're going to do 2 pi divided by b. So 2 pi divided by 1 is still pi. Our starting point, c over b. So c over b, negative pi over 2 divided by 1 is still negative pi over 2, comma d, which is 3. All right, guys, we feeling good about what we've created so far. All right, so let's go ahead and attack that starting point. Remember, we're going to build a frame. Now, while I can't technically say that you absolutely must do it this way, I highly encourage you to do it this way. Again, remembering back to January when we quizzed and tested over this stuff, for the most part, definitely not with 100% accuracy, but the majority of the students who struggled, it was that they either were not building the frame or they were building the frame incorrectly. Okay, so again, if you're only kind of paying attention today, this is where you're going to want to kick it into gear and convince your brain to focus in right now. Okay, so our starting point is at negative pi over 2 comma 3. We're going to plot at negative pi over 2 comma 3. That's where we put our first point. All right, so we're going to go ahead and build the frame. So remember what the frame, it's just a giant rectangle is all that it is. But if we do this properly, it's going to take care of any vertical or horizontal stretching or displacement that's going to take place at all. We're going to take care of this in its entirety. So the way that we're going to build the frame is we're going to move from the starting point up the amplitude, which we said was 1, down the amplitude, which is 1. Then we're going to move over to the right 1 period. So we claimed that the period was 2 pi, so I'm going to move over the amount of 2 pi. Not until I get to 2 pi, but we're going to move over the amount of 2 pi. Now this is my outer frame. Could somebody remind me, please, once we have the big rectangle, what we have to do? Yeah, we're going to have to start to do the divisions, right? So we have to cut it in half horizontally. And then what do I have to do vertically? We're going to break it into fourths. So that means we cut it in half, and then we cut each half in half. All right, so this is our frame. Outstanding. Now let's think about a quote-unquote parent function for sine. I always forget. Does the sine curve go through the origin, or is that the cosine curve? Which one goes through the origin? Sine goes through the origin. Also, sine goes up, then comes back down. This would be 1 period or 1 cycle of the sine function. So that means that if we typically go through the origin, should we expect to go through the starting point? Absolutely. And under normal circumstances, we would go up as we move to the right. But these are not normal circumstances because we said that we're reflecting. So instead of moving up, in this case, we're going to move down and then come back up, move around this way. So what we were able to just create was the sine curve. That's 1 period. Does everybody see now why we break this into fourths? Is because these are all spaced out very evenly. It's just like when we're graphing the rose curves that, okay, I know that the petals are all going to be spaced out evenly. It's just that with the rose curves, it's harder because it's dependent upon how many petals we have as to determine the spacing. Here, the spacing, we're doing the same thing. It's just that we're dividing the period by 4. We break it into fourths. So one of the other aspects that you may be asked to do on Friday is to identify these significant points. Do we suppose we could do that? Do we identify where those points are located? We know where the starting point is, negative pi over 2 comma 3. What about this point? 0 comma 2. Then we're at pi over 2 comma 3. Running out of space here, but we are now at pi comma 4, ending up at 3 pi over 2 comma 3. All right, guys, how do we feel about identifying those points at the end? How do we feel about how do we feel about figuring these out? Now, what about domain and range? Okay, domain and range. Not so much that that's going to factor in, but do we agree that all these sine and cosine curves, the domain is going to be infinite, from negative to positive infinity? The range is just the